Planning effectively is the key to achieving a successful implementation. In this series of design and implementation tutorials, you'll learn design best practices and how to troubleshoot, analyze, and use the provided system monitoring tools to improve performance and customer experience. In this tutorial, you'll see how to follow best practices when building calculations and how to troubleshoot calculations. To create efficient business rules using best practices, you should be familiar with your application and your database outline. You should also have an understanding of how data is stored and aggregated, at what level data is loaded into the database, the required calculation order, and key assumptions that drive your calculations. For more information on creating business rules, please visit the PBCS Help Center. Calculation Manager is a graphical tool that business users can use to create business rules. In designer mode, you can drag and drop components and templates into the graphical flowchart. You can select components in the flowchart to edit or view their parameters and properties. Behind the scenes, Calculation Manager creates a calculation script based on the rule's graphical flowchart. You can edit the created script directly, and you can also create your own scripts from scratch. Whether you're working in the designer or creating your own scripts, here are some best practices for reducing script maintenance and analyzing and troubleshooting your business rules. Let's take a look at some best practices for reducing script maintenance. I'll start a new business rule. Many business rules reuse the same sections of code. You can use templates in your rules to avoid having multiple iterations of the same code and to reduce your overall maintenance. You can leverage system templates as building blocks for your own custom templates. Create custom templates by using the Actions menu to save your current script as a template. I can now use this template in any rule where I need to clear budget data. Note, you can create custom templates from any script. They don't have to contain system templates, as in this example. Here's another common rule management issue. In many cases, business rules are the same and vary only by a baseline dimension member, scenario or year, for example. In this example, I have identical income statement scripts that vary by scenario. Instead of using separate rules, I'll use a runtime prompt to leverage the same rule for both scenarios. First, save the rule with a new name. Next, select the value to be prompted for in the fix statement and click the Variable button. Select or create a runtime prompt variable. I already have a runtime prompt variable for actual and budget, so I'll select it and click OK. When you launch the script, you can see the prompt. Tip: for business rules associated with web forms, you can leverage the selected page and POV members as runtime prompt members. For enterprise-type applications, you can improve performance and script maintenance by creating rules in the Groovy scripting language. Use Groovy rules to dynamically generate focused calc scripts based on the context of the current form. For more information about Groovy rules, please see the PBCS Help Center or watch our tutorial video integrating strategic models using Groovy rules. Calculation Manager also gives you tools to analyze and troubleshoot your rules. We'll look at the Debug tool, the Analyze Script tool, the Errors and Warnings tab, and the Log Messages tab. Let's take a look at how debugging works. I'll select Debug from the Actions menu to open the tool. Notice that Debug lets you insert breakpoints in your script to check values at that point in the script. In this example, I'm assigning values to products if their color attribute is pink. I also have an else statement that assigns a value if the product isn't pink. Let's make sure we're getting the correct value for P000, which is a pink product. I'll insert breakpoints for both lines that reference P000 and run the script. Notice that the debugger stopped on the else line, and you can see that P000 was assigned a value of 500, not 105. That means the product isn't meeting the condition. I'll open P000 in Dimension Editor to see what's going on. Notice that P000 has no assigned attributes. I'll assign the pink attribute, save my changes, and then refresh the database. Now I'll try debugging my script again. This time, notice that the debugger stops at the first correct breakpoint, and I'm getting a value of 105 for the product in January. Clicking Resume 2 more times iterates the calculation through the scope of the fix and shows me corrected values for February and March. 1 more time and the debugger is done. If your calculation scope is very large, you can add conditions to your breakpoints to limit the debugger. I'll right-click my first breakpoint and limit the debug to January. This time, when I run through the debugging process, only January is checked, and then the process ends. With complicated rules, it can be hard to pinpoint problem areas for a performance analysis. If you want a detailed breakdown of how each section of your script performs, use the Analyze Script tool. I'll select Analyze Script from the Actions menu. On the Script Analysis tab, the section of script that took the longest to execute is highlighted in red. In the Information panel, you can see the execution time and percentage of total execution, block count, number of potential blocks, number of counted blocks, and the scope of the calculation. You can click on other parts of the script for analysis information as well. The Diagnostic information on the Errors and Warnings tab provides valuable tips for improving calculation performance. This sample rule is built intentionally to generate warnings. Notice that the rule is technically correct and will validate with no errors. I'll go to the Errors and Warnings tab and run a diagnostic. First, you see a summary where you can see information like the total affected cells, number of passes, and number of improper dimension usage. Each warning message provides a description and a line number in the script. For example, this warning says, using a calc mode of cell can lead to performance issues. You can right-click the warning and select to show the related line highlighted in a script view. Or you can right-click the warning and select to show the related component highlighted in the designer. Use the warnings to guide you in your script editing process. The log messages you get when you run a rule can also help you diagnose what the rule is doing and improve performance. In this example, notice the multiple fix statements. I'll launch the rule. Now let's look at the log messages. You can change the view to condense the messages by calculation pass. As expected, all those fix statements produced multiple database passes. We have 4 in this example, and the cumulative time for the entire script to run is 0.019 seconds. I'll revisit the rule and see if I can combine any fix statements to reduce the number of passes. Notice that the script blocks inside the 2 fix statements on year, scenario, and version are identical, and the fix focus in those statements only varies by 1 member, FY17 and FY18. I'll focus on both years in the same fix and remove the duplicate code. Not only will that clean up the code considerably, but it will reduce the number of passes on the data. I'll run the script again. This time, you can see there were only 2 passes, and the cumulative calculation time is only 0.008 seconds, a big improvement over 0.019 seconds. In this tutorial, you saw how to follow best practices when building calculations and how to troubleshoot calculations. To see the next video in this series, click the link on the right. To learn more, visit cloud.oracle.com.